Part C. So when t is equal to q, the acceleration of our particle p is 0. So when t equals q, the acceleration of p is 0. Now there's two parts. We want to find the value of q, and we hence want to find the speed. It's very important. This is a word we haven't seen much in past exams in the past. It's speed, not velocity. So the speed of p when t equals q. So when the acceleration of our particle is 0, we know that acceleration is just the first derivative of velocity. And the first derivative is the slope. So when's the slope of this velocity curve 0? And that's going to occur here at the minimum. Right here, the slope, if we create a tangent line, will be 0. So this is going to be point Q. So on our velocity curve, we want to find where that is. So let's go back to our graph. So we can find that by just finding the minimum. So menu, analyze graph, minimum. And the x-coordinate is the time, and the y-coordinate is actually the velocity, because this is a velocity curve. So when the question says find the value of q, q is the time where this happens. So using GDC, our graphics display calculator, and I'm just going to say I graphed it, graph the min, q is equal to, and it was 1.95 seconds. Now in part 2, it says hence find the speed of p when t equals q. So it's going to be at this point q. We want to find the speed. Now we know the velocity is negative 1.76, but velocity has negative and positive values depending whether this particle is moving forwards or backwards, if you want to think about that. So speed is actually just a positive value. So speed does differ to velocity. So speed will be this value here, negative 1.76, but made positive. So I'm going to write down that the velocity at 1.95 equals negative 1.76. This is centimeters per second. So therefore, the speed is equal to positive 1.76 centimeters per second. So it's very important you know the difference between speed and velocity. Okay, that's the answer to part C.